Right. So the first trend we'll look at is the size. Obviously, different elements, different atoms are different sizes. I think back to the beginning of the course, we said that the majority of the volume of an atom are the electrons. So what we're really looking at here are the electrons. So as we can see, here's a little periodic table based on the size of the atoms. Obviously, you don't have to draw this whole thing out. You can just draw a little, outline of a periodic table. So what we can see is that generally when we go towards the bottom left, we get bigger. And so there's two trends that are occurring here. As we go down, we get bigger. And that's relatively easy to explain. As we go down the periodic table, n increases. Remember, n is our principal quantum number. So when we have n equal to 1, we only have one major energy level for the electrons. When we get down to like n equals 3, then we have 1, 2, 3, right? As you can see, as we grow these orbits, they get bigger and bigger, and that explains why we go down the periodic table, we get bigger and bigger. The other trend that's a little bit weird is when we go left to right, we get smaller. So even though when we're going left to right, we're adding electrons to our atom, we're actually getting smaller. So let's take a look at why and try to make this nice and logical. And that has to do with Z effective, which is the effective nuclear charge. Z effective here is going to be equal to Z minus S. Z is the number of protons. While S is shielding electrons. And we'll get to what that means right here. So let's think about our atom of boron. So our atom of boron is going to have 5 protons. So in the nucleus, we have 5 protons. And then, of course, we have our n equals 1 orbital. And then we have our n equals 2 orbital. In our boron atom, we have 2 electrons in the n equals 1, right? Our 1s2 electrons. And then in the n equals 2, we have the 1s2 and then, or my bad, the 2s2 and the 2p1 electrons. So we have 3 electrons out here. And so if we think about the interaction between the nucleus and the electrons, we can see that our n equals 1 is between our nucleus and our n equals 2 electrons. So these electrons are actually going to shield the n equals 2 electrons from the effect of the nucleus, right? So n equals 1 electrons shield the n equals 2 electrons. And so since they're more core electrons. So if we think about what the Z effective here would be, we have 5 protons, and then we have 2 shielding electrons, 2 core electrons. So we get a number of plus 3. So what that means is that each of these valence electrons, they each feel 3 protons, right? Remember that opposite charges attract. So for example, if we took a look at lithium versus fluorine, right there in the same row, right? Lithium is right here, fluorine is right here. So why is fluorine smaller than lithium? So it has to do with this effective nuclear charge. So lithium has 3 protons, while fluorine has 9 protons. So we have our little nuclei, and then we have our orbitals. We have our n equals 1 orbital with its 2 electrons. And then in the case of lithium, we just have 1 equals, just 1 electron in the n equals 2 orbital. If we think about what Z effective here is, right, we've got 3 protons, and then we've got 2 shielding electrons, so plus 1. So this outer electron just feels essentially 1 electron. Then for fluorine, right, we've got the same 2 electrons in the n equals 1 orbital. And then if we think about how many we have in the n equals 2, we have 5. 1, 2, 3, 4, 5, right? The 2s2, and then the, oops, we have 7, 7, and then the 2p5. And so if we calculate the Z effective here, now we have 9 protons, but we still only have 2 shielding electrons because we still only have two core electrons. And so that leaves a Z effective of +7. So what that means is that all 7 of these outer electrons feel the pull of 7 protons. And since opposite charges attract, that nucleus is going to pull those protons closer and closer together, and so our atom gets smaller and smaller and smaller, right? The power of technology there. So what you want to know is you want to know the trends and you want to know the why, right? As we go down the periodic table, N is increasing, so we're getting our atoms are getting bigger and bigger. And then when we go from left to right, we're getting smaller because we're increasing the effective nuclear charge. Because we're increasing the number of protons, but we're not increasing the number of shielding electrons. So overall size is a very important component when it comes to chemical bonding. But it's something that's not quite pronounced as much in the intro courses. So when you take like CHEM102, or really when you take OChem, then size will be a bigger factor. But for now, we're not going to focus on it too much. All right, so you can see the arrows, right? They say left to right, increasing atomic radius, down, increasing atomic radius. Well, so if we were to take a look at oxygen and then look at one to the left of it, and then one below it, which atom is bigger? And if you look at the numbers, nitrogen is about 70, while sulfur is 103. And so going up or down the periodic table has a larger effect than going left to right or vice versa, right? So increasing the number of energy levels, the N has a bigger effect on the size than changing the effective nuclear charge.